Today, as you are all aware about the schedule, that we are going to discuss on classification and clustering, and I have been entrusted to take a session on classification and clustering. So before taking a virtual class, I will request all the participants that if during my session, if there are internet issues, if you cannot hear me properly, or if there are certain problems with the connection, you just unmute yourself and talk with me so that I can be alert. And I will be in the first half of the session, I will be discussing about the theoretical aspects of cluster analysis and how we will proceed to understand that. And in the second half of the session, I will try to do a hands-on workshop on how to do cluster analysis through SPSS. I have already shared the data set with you as well as the PPT. So I will be using the PPT for the first half of the session and will do a hands-on on the data set on the second half of the session. If you have the facilities of SPSS with you, so you can do along with me the hands-on session. Otherwise, you can follow the instructions and follow the procedures that I am going to follow. But I will request you all that if you have a laptop or a desktop, and if you have the SPSS version with you, you should do along with me. That's why I have shared the data set beforehand. So are we going to start the session, or all of you are ready?
Yes, sir.
Okay. So sometimes
স্যার ল্যাপটপের ক্যামেরাটা উঠে গেছে, ডাউন করুন তো। হ্যাঁ, correct.
So when we will be discussing the theory, we will be trying to write something as well so that you can understand not only the PPTs, so that our conceptual clarity is clear. And I think as per the schedule, in today's first half of the class, Professor Subhashish Bhattacharya has taken a class on principal component analysis, I think. So you are all aware about factor analysis. Cluster analysis is another type of unsupervised learning, where actually in case of factor analysis, we also do grouping. In case of cluster analysis also we do grouping, but the algorithm or the mathematics behind the two is altogether different. So can I assume that you are aware of the factor analysis? You can use the, if you cannot unmute, you can use the chat box as well. So I can assume that you are aware of the factor analysis or principal component analysis. Are you aware? Please, yeah. Okay. So I will like more participants to be involved in the session. Otherwise, since this is a very virtual class, I cannot see you, I cannot hear you. So if you use the chat box, then it will be better for me to understand that you are with me. And sometimes you may also unmute and talk with me if there is certain issues that you need to understand verbally. So let us start now. I will be sharing my screen, and when I share the screen, due to internet issues, I will switch off my camera, and I will try to give you a basic idea about the cluster analysis. Beforehand, I will start with a little bit of factor analysis, and then I will go to the cluster analysis in order to make a relationship between factor analysis and cluster analysis. So before starting the class officially, as I always start my class with a prayer, so let me start with a prayer and then we will go directly to the class. Om. Lead us from unreality to reality. Lead us from darkness unto light. Lead us from death to immortality. Om. Peace, peace, peace. So you will just tell me that whether you can see my screen or not. I am sharing my screen. Can you see my screen?
Yes, sir.
Yes.
Okay, thank you. So we are going to discuss cluster analysis today. So can you read what I am writing?
Yes, sir.
Now,
Sir, cluster analysis.
yeah, just to have a recap that when we were talking about factor analysis, what we generally do in factor analysis is that suppose there are n number of observations. And say there are p number of variables. And these are called manifest variables or latent variables. And what we do is, on the basis of these observations, in case of factor analysis, we group variables. And we group variables into factors. Say, if 1 is factor 1, if 2 is factor 2, say if n is factor n. Suppose we have these two variables which are closer to each other, we are putting it under factor 1. Similarly, other variables we put under factor 2. Then the rest of the variables we put under factor n. So this is how we actually, which is called this factor analysis is another name of factor analysis is called a dimension reduction technique. So we actually reduce the dimension, we reduce the variables into factors. This is the basic objective behind doing factor analysis. Now, in factor analysis, we are also grouping the variables. In case of cluster analysis, also we are grouping, but we are grouping the observations. So when we are grouping the observations, we call it as cluster analysis. Now, in case of cluster analysis, the respondents or the observations or the objects have certain characteristics or features. So here x1, x2 will be some characteristics or features. And on the basis of the characteristics or features, we group these number of observations. When we group these observations, we call it as clusters. Say suppose 1 and 2 under cluster 1. Say 3, 4 under cluster 2. This is how we do a cluster analysis. And in case of factor analysis, we group variables or latent variables or manifest variables. In case of factor analysis, we group variables, latent or manifest variables. In case of cluster analysis, we group observations or objects or items. Now, both in case of factor analysis, in case of cluster analysis, we are grouping it, but the mathematics behind the grouping, the algorithm behind the grouping is different. Basically, in case of factor analysis, the measure of grouping is called the correlation measure. We use the correlation. That's why we call correlation measure. And in case of cluster analysis, the mathematics or the algorithm behind grouping is called the distance measure. We call it as distance measure. The distance measure may be on the basis of similarity or dissimilarity. So this is okay with you? The concept, what is cluster analysis and what is factor analysis? Have you got it?
Yes, sir.
So now let us go to the PPT. I think the PPT is visible.
Yes, sir.
Okay. So as we have already understood that in case of cluster analysis is called the multivariate technique because you have n number of observations or n number of respondents or n number of products, and on the basis of the characteristics of those, we are grouping it. So grouping is based on certain attributes, and the main purpose of cluster analysis is to make sure that the groups are within the groups it is homogeneous and across the groups it is heterogeneous. So if there are three groups, it will be a good cluster analysis if the three groups are altogether different from each other. But within the group, it should be homogeneous to each other or should be similar to each other. And therefore, the distance measure is being used when we use cluster analysis. The basic algorithm behind cluster analysis is the distance measure. And since we are grouping the objects or the respondents or the observations, the other name of cluster analysis is also classification technique or classification analysis. Now, can anyone say what this diagram is? What is the name of this diagram? What is the popular name of this diagram?
Scatter diagram.
So scatter plot.
Is it scatter
Yes.
diagram, sir?
What is the name of this diagram?
Scatter diagram.
Yeah, scatter plot.
Scatter
Actually,
plot,
this is
yes, sir.
plot of scatter diagram. Yeah, you are correct. I am audible, I think. My voice is clear to you.
Yes, sir. Yes, sir.
Okay. Now, here, if you see the scatter diagram or the scatter plot, what you may say, how many groups are here?
4.
Four.
Yeah, distinctively there are 4 groups. So from the different colors also we can see that there are 4 groups or 4 clusters, and the clusters within them are similar to each other and across them are altogether different to each other. Now, through cluster analysis, if we use SPSS or for that matter any other software will create this cluster diagram or is scatter diagram of this scatter plot. I will come when I will give you a hands-on session. There I will show you how to draw this scatter plot with the help of software. Now, if you see these two diagram here, in the y-axis, we are measuring variable 1, and in the x-axis, we are measuring variable 2. And the first diagram is after doing cluster analysis, and the second diagram is before doing cluster analysis. So when we are plotting the variables, the plot looks like diagram 2. When you apply the cluster analysis technique on this diagram or on these objects or respondents, or for that matter on the data, you come up with figure 1 or diagram 1, which distinctly shows that from the scatter plot there are 4 clusters or groups. So the basic idea behind doing cluster analysis is to form clusters or groups on the basis of similarity or dissimilarity among the objects. Now, I have started today's session by talking about cluster analysis and factor analysis. And I have mentioned that factor analysis is a dimension reduction technique, whereas cluster analysis is a classification technique. Both of them deal with grouping. But the grouping in case of factor analysis is based on correlation measure, whereas in cluster analysis, the grouping is based on the distance measure. And the statistics behind cluster analysis we will talk about is, say, the distance measure can be, there are different methods of measuring distance. There you may use Ward's method, centroid method. There are different methods I will come across, and from the dendrogram or the agglomeration schedule, it will help us to understand that what should be the exact number of clusters. Whereas in case of factors, when you are drawing a factor analysis and you are trying to understand how many factors are there, you use the eigenvalue or the factor loading. So the mathematics is different. Now, there is another analogy between cluster analysis as well as discriminant analysis. In case of cluster analysis, you should understand that whether factor analysis or cluster analysis, you don't have the requisite knowledge about classifying the variables into dependent and independent variable. So when we cannot actually classify the variables or determine the variables as dependent or independent variable, we call it as unsupervised learning technique. And factor analysis and cluster analysis both comes under this unsupervised learning technique. The other name of this technique is called interdependence technique. Whereas when we can classify the variables into dependent and variable, we call it as supervised learning technique. The other name of supervised learning technique is dependence technique. Discriminant analysis is a supervised learning technique, whereas cluster analysis is an unsupervised learning technique. The basic difference is that in case of generating cluster membership or grouping the objects or the respondents or the observations, in case of cluster analysis, you don't require any previous knowledge. But in case of classifying or discriminating between groups with the help of discriminant analysis, you should have a prior knowledge about the groups, the group membership. On the basis of that, you classify the groups. So discriminant analysis is also a classification technique, but the fact is that you have to have the knowledge about dependent and independent variables in order to run discriminant analysis. But in case of cluster analysis, you don't need to determine that what variables are dependent and what variables are independent in nature. Now, generally, cluster analysis have been in use for long period of time, and generally in case of psychology, in streams like psychology, biology, in case of World Wide Webs, this cluster analysis technique is widely used. Not only that, nowadays we are very well aware of this climate change, and therefore in order to predict the climate, cluster analysis is also being used now. But most application that cluster analysis is applied, or the major application, is in marketing research. When you are segmenting the market, when you are understanding the buyer behavior, when you are trying to launch a new product in the market, cluster analysis is used. And basically we will try to understand that cluster analysis, when you have a huge data set, in order to make the data manageable, make the data interpretable, generally cluster analysis is used. Cluster analysis is also a general data reduction tool where individual observations are being clubbed into groups or clusters, and therefore automatically there is a data reduction. So now you can think of cluster analysis as a process model as well. Generally in process, we know that there is input, there is process, and there is output. Here, what are the inputs in case of cluster analysis? The inputs are the observations or the objects or the items which you have with you. And you have the characteristics or features of those objects or observations. And that is the input to you. Now, what you do with this input, you try to obtain the similarity, dissimilarity measures by applying the distance measure. You partition these objects into groups, and the output that does come is the number of groups or number of clusters. Now, let us come to understanding of how cluster analysis works. The primary objective behind doing cluster analysis is to define the structure of the data by placing the most similar observations into groups. I was talking about that the groups should be homogeneous within the group and it should be heterogeneous across groups, and the homogeneity or the heterogeneity is derived by understanding the distance measured among the items. So when we are trying to measure the distances, we automatically understand that whether they are close or whether they are far from each other. And therefore, we must address three basic questions when we are doing a cluster analysis. The first question is, how do we measure similarity? The second question is, how do we form clusters? And the third and the most important question is, how many groups do we form? There are how many clusters we are going to form from our data set on the basis of the distance measure that we are going to adhere to. Now, there are certain criteria that we need to understand before applying cluster analysis. The variables that we are going to consider are important variables because you have enormous number of variables in your study. Some variables are important, some variables are not so important. So you should discard the unimportant variables and you should take into consideration the important variables only. When I will be doing a hands-on session with the data set, I will try to make you understand that how we discard the unimportant variables and how we consider the important variables, on which basis we will understand that which variables are important to us and which variables are maybe discarded, maybe not so important to us. So we may discard those variables from our study. So that is also a very important thing to understand when we are doing research, that variables we may consider initially, but when we are trying to do a analysis, trying to do a study which will be of meaningful to us, we should know how to differentiate between important and unimportant variables, and how to keep the important variables in our study and how to discard the unimportant variables from our study. And already few days have gone by in your workshop. You know that generally variables are measured in scales, and there are 4 scaling techniques, that is nominal, ordinal, interval, and ratio scale. Generally nominal and ordinal are categorical data, and interval and ratio are scale data or continuous data. Now, generally when we try to apply cluster analysis, we generally try to consider the distance between the objects or between the items, and therefore distance measure is very critical in cluster analysis. Now, how do we measure similarity or dissimilarity? Now, similarity represents the degree of correspondence among objects across all the characteristics used in this analysis. Generally, I was talking about that similarity means nothing but the degree of correspondence between the objects or between the respondents or between the observations. And when you are trying to group these items or objects or observations, you should follow certain rules. Generally, there are two types of measures. I have already spoken, that is correlation measure and distance measure. Correlation measure is frequently used in case of fractal analysis, and distance measure is frequently used in case of cluster analysis. Now, if you see two graphs here, can anyone provide some insights about these two graphs? Either they are same, they are similar, or there is any difference between these two graphs? Can anyone say? By looking at these two graphs, what you understand?
Sir, in graph 1, the distance between two lines are less in comparison to graph 2.
See, if we want to see these two graphs on the basis of suppose you are using the correlation measure, okay? So when you are using correlation measure here, in both the graphs r is equal to 1, means the correlation is same. So if both the correlation is same, you will hardly find any difference between the two graphs. But if you apply the distance measure, you will find that the distance between line 1 and line 2 in graph 1 is closer than in graph 2. So when you are applying cluster analysis, here we are not bothering about the correlation measure, but we are trying to understand the pattern of the graph or pattern of the data set, and therefore we give much importance on the distance measure. So both the graphs, correlation measure is same, r is equal to 1, but the distance measure is different. In graph 1, the distance is much closer, and in graph 2, between the two lines, the distance is much wider. This is clear to you?
Yes, sir.
So that's why you may say, on the basis of similarity or dissimilarity, graph 1 is between the two lines in graph 1, there is much more similarity than in graph 2. Now, here, when we are applying the distance measure, basically there are 5 methods which we can use. One is Euclidean distance, second is squared Euclidean distance, third one is Manhattan distance, fourth is Chebyshev distance, and fifth is Mahalanobis distance. Now, if you want to understand the derivation of the formula of these methods, I will recommend you one good book, that is Hare's book on multivariate data analysis by Hare. You can go through that book and you will be able to understand the formula, that how this formula is being generated in order to measure this distance. But today I will not go on those derivation of formulas and not bore you, because nowadays when we are using softwares, we only try to understand the formula, and if we can, in our papers and in our research work, we only try to write the method that we have used and the formula that we have used. The results are automatically generated by the softwares. So derivation of formula, how this formula is coming, those things are not so important nowadays now. But if you have interest in understanding the formulas and how it is being derived, you can follow the book that I am recommending to you, that is Hare's multivariate data analysis. That book you can go through and you can understand the derivation of these formulas. But today we are going to use the softwares, and we should try to understand the results, that how cluster analysis is being done and what is the interpretation. And therefore I will tell you that among these 5 methods, the squared Euclidean distance is the most popular method, because when you are squaring the differences with the help of square root, and when you are summing the square differences automatically, you take the absolute figures, and you the negative figures are also being squared up. That's why squared Euclidean distance is the most popular method that we use nowadays. Now let us come to how do we form clusters. Generally there are 3 types of clustering technique. One is hierarchical clustering technique, second is non-hierarchical clustering technique, and the third is the hybrid one, that is the combination of hierarchical as well as non-hierarchical. We call it as the 2-step cluster analysis. So if time permits, I will try to run the 3 cluster analysis technique, that is hierarchical, non-hierarchical, as well as the hybrid one. The hybrid is most popularly called as 2-step cluster analysis. The non-hierarchical, the most popularly the non-hierarchical method is called the k-means clustering. Here k means the number of clusters, and the first one is the hierarchical technique. Generally what happens is when you are applying the distance measure, the similarity, how close to each other, we apply those 5 distance measures, and among those 5 distance measures, the squared Euclidean distance is the most important, that I have already mentioned. And generally what happens is when you are applying a hierarchical clustering technique, you will find that there is a dendrogram. The dendrogram is nothing but the from the agglomerative schedule, we try to understand a graph which is a tree-like picture, and the tree-like picture tells us that we move from one cluster to the other cluster on a stepwise basis. If I show you the dendrogram, it will be much more meaningful to you. If you see the dendrogram here, this is a tree-like structure, and you will find that here, if you see here that B, C, and D, they are within one cluster. Similarly, E and F is within one cluster. G is another, a separate cluster altogether, and G is much more related to E and F, whereas B, C, and D are related to each other. So from the tree-like structure of the dendrogram, you will be able to understand that which observations are closer to each other and therefore fall in which cluster or group. So the other name of dendrogram is the graphical tree graph, we may say. This is through hierarchical clustering technique we find this dendrogram, and basically initially we start with that each observations are belonging to each cluster or a separate cluster, and as we move step by step we see that actually all the observations belong to a single cluster. So initially we start with that all the observations are belonging to a separate cluster, and ultimately as we grow further, step by step as we go ahead, we find that all the observations come under a single cluster. That is how this dendrogram or the tree graph is being depicted. The software will automatically generate this dendrogram. Don't worry, I will show you how this dendrogram is being generated. Now, there is a very popular concept of outliers. Now, you know that in any multivariate data analysis or any statistical technique, if your data have outliers, you need to remove those outliers first. Otherwise, if you keep the outliers and if you don't know how to remove the outliers, if you retain the outliers in your data set and if you run the statistical analysis, the result will be not much powerful. The result will be insignificant. So in order to make your result significant, you need to understand the outliers and you need to remove those outliers. So in case of undersampling, if your sample size is not big enough, you may retain these outliers. But the fact is that if you have a proportionate size of your sample, if your sample size is good enough, you need to remove these outliers in order to make your results significant. Now, I'm talking about outliers. How you detect outliers, how you can identify that outliers are there in your data set. So the first case, in case of our, when you are trying to run a cluster analysis, if you find that if there is huge distance or large distances between the observations, you may understand that there is an outlier. And if you run a profile diagram of the data set first, if you run a box plot or a histogram, you will understand that whether there is outlier or not. And I will show that how the box plot is generated and how the box plot will help you to understand that whether there are outliers or not. Another important thing is about the sample size. And as a researcher, we should ensure that our sample size is large enough. Because if our sample is representative of the population and if our sample size is large enough, then we feel confident while running any multivariate data analysis. So when you are trying to run cluster analysis, you should make sure that your sample size is large enough. Another important concept that we should understand before applying cluster analysis is that when you are measuring data or capturing data, you have different scales. You may measure it in ordinal or nominal or interval or ratio scale. Now the fact is that if your data sets exhibit different scales, if it is not measured in a single scale, you cannot apply cluster analysis. So before doing cluster analysis, you have to convert it into a standardized measure. And the standardized measure may be minus infinity to plus infinity, or you may use Z-score as well. Generally, when we use Z-score, we mean that the mean is equal to 0 and standard deviation is equal to 1. And it is better that if your data set is in different scales, if your variables are in different scales, if it is measured in different scale, you standardize it first with the help of Z-score, and then you run the cluster analysis. So standardizing the data is very important when you are running a cluster analysis. So already I have mentioned these three techniques of deriving cluster, that is hierarchical cluster analysis technique, non-hierarchical cluster analysis technique, and the combination of the hybrid one. Now, the most important here is that when you are applying a hierarchical clustering technique, you generally use a dendrogram, and the dendrogram or the tree graph will help you to understand that how many clusters you should select. And the algorithm behind it is the agglomeration schedule that we will use while doing the hierarchical cluster analysis. But the main point here is that generally there is restriction in case of sample size when you are doing a hierarchical cluster analysis. If you have 300 to 400 observations, or if your sample size is within 300 to 400, it is better to use hierarchical cluster analysis. And when your sample size becomes bigger, say if it exceeds 1000, 1500, 2000 or more than that, hierarchical cluster analysis technique will not be the appropriate technique, then you have to use k-means or the non-hierarchical clustering technique. Now, let us come to the agglomerative algorithm that we are going to use in case of hierarchical clustering technique. The agglomeration schedule may be prepared by using different methods. The first one is the linkage method, which we call as single linkage, complete linkage, and average linkage. Then there are centroid method. Then there is words method. Generally, the words method is words and centroid method is popular when there is when the observations are closer to each other. When we are measuring the closeness, we use the single linkage. When the observations are much far from each other, we use the complete linkage. And centroid is the average method. Average between the when you are trying to measure the mean of the groups, and when you are trying to measure the distance among the means of the groups or the clusters, you use centroid method. And the words method is popular, but the problem is that in case of word method, more or less the cluster size is more or less same. Means, say if there are 18 observations in one cluster, then there will be say 19 or 20 observations in another cluster. But in case of centroid method, there may be 2 observations in one cluster, there may be 20 observations in another cluster. So using centroid method is much more practical, and we will be using the centroid method when we will be using the hierarchical clustering technique. So what I was mentioning here, if you see that here there are 2 groups or 2 clusters you may see from the diagram, and when you are measuring the closeness, the 2 points from the 2 groups or clusters, when you are measuring the closest one or the nearest one, we call it as a single linkage method. If you come here, you will find that we are measuring the distance among the 2 farthest points. When you are measuring the distance between the 2 nearest point, we call it is the single linkage. When we are measuring the distance among the 2 farthest point between the 2 groups or clusters, we call it as a complete linkage. Average is, you know that we have to measure all the points from each other, and we actually do the average among the distances. Centroid method, I was mentioning that what you do is you find the mean of the individual groups, and when you are measuring the distance among the mean of the individual groups, here we have 2 groups. When we are measuring the mean among the 2 groups, the distance among the mean of the 2 groups, we call it as a centroid method. So more or less, I have discussed the theoretical aspect. Now, generally, when we will be going to run the cluster analysis by applying the 3 methods, that is hierarchical clustering and k-means and 2-step cluster analysis, the most important part is that how we interpret. The interpretation of the cluster is very important. Now, generally, you have to understand that whether there is substantial variation between the clusters or not. It should be examined, and you have to understand that whether there are substantial differences in each cluster's profile and among different clusters' profile, and you need to understand the correspondence between the clusters. And therefore, what we do is we will have to apply a validation technique whereby it will ensure us that the clusters that we have generated are significant or not. So validation is very important in case of applying cluster analysis technique. Generally, in most of the cases, this validation is avoided. But in order to make your study much more reliable and valid, you should apply these validation techniques. And there may be predictive validity, there may be cross validity, I will show you how to run these validation techniques in order to make your clustering valid. So when I will be going for a hands-on session, I will show you how we can use these validation techniques in order to understand that the number of clusters that we have generated are truly homogeneous within the groups and heterogeneous across the groups, that can be established with the help of the validation techniques in cluster analysis. So this is in a nutshell the theoretical concept. When we go on to use the software, it will be much more appreciable for you that if we can understand it in proper perspective, we can use this cluster analysis very often in our research. So till now, if you have any doubt, you may ask me. Our theoretical concept is over. We will now go on to do a hands-on session on the data set that I have already shared with you. So before going for a hands-on session, if you have any queries or if you have any doubt regarding the theoretical concept, you may ask me, or otherwise we will take a 5 minutes break and we will proceed towards a hands-on session. I will give you a 5 minutes time. You better be ready with your laptop or desktop and with the data set that I have already shared with you. Then we can do a hands-on session. And I think the hands-on session will be much more fruitful and effective if you do along with me. I will go slowly as far as possible. And if I go little fast, you may unmute and tell me that I'm going little fast. I will reduce my speed. So how many of you will be able to do hands-on with me? How many of you are ready with the data set with your laptop? You may use, yeah, that is good. So if you have any doubt regarding the theoretical concepts that I have tried to share with you, you may ask me, or otherwise we will have a 5 minutes break and we will start our hands-on session then. If you have any query, you may ask me. Just unmute yourself and talk with me if you have any queries.
Yes, sir. Is it possible you share any articles or something so that we can able to understand how to interpret that cluster analysis, or you will tell us during the session that how to interpret the cluster analysis?
I will do a hands-on session now, and with the real data, I have shared a real data set with you. It is actually a real data set, and I will show you not only how to do the cluster analysis, but how to interpret it, so that with your own data set, you can handle those things. Okay.
All right. Okay. Thank you so much.
So any other queries or question? No queries, no question. Okay, then we take a 5 minutes break. Now it is 5:53. So we will be joining around 5:59 and I will start the hands-on session at sharp 6. Okay. Okay to you all?
Okay. So one more thing, that it's the cluster analysis is better for the marketing, right? For marketing topics or for any other topics, or it's far better for marketing one, more suited for marketing topics.
No, most popularly it is used in marketing research, but nowadays in biology, in psychology, in weather technology, climate change, everywhere this clustering technique is used. If you understand the nitty-gritty of this cluster analysis, you may use in your fields as well, no issue. Okay, then we take a 5 minutes break and we join for the hands-on session. So let us join after the break. Are you with me?
Yes, sir.
Just use the chat box and reply that you are ready for the hands-on session. Just type R, ready. So I can assume that those who are typing R will be doing a hands-on with me, are ready with the data set and the laptop or the desktop. So let us start today's session, the hands-on session. Let me share my screen. Can you see my screen?
Yes, sir.
So just double click the data set which I have shared with you, and you will see this data set. The data set is in the screen. Have you opened the data set? Just open it. So when I am sharing the screen, I will not be able to see the chat box. So you unmute yourself and talk with me if you have any thing to share with me, or if you want to understand anything. Just unmute and talk with me, because I will not be able to see the chat box when I am sharing my screen. So have you opened the data set?
Yes, sir.
Yes, sir.
Yes.
Okay. So let us try to understand the story behind the data set and what we are going to do now, because first we need to understand the data set and the why we are going to do cluster analysis. So just if you go to the variable view, you will find that certain variables are measured in scale. Scale means either interval or ratio. So basically SPSS understand three measurement. One is nominal, other is ordinal, and the third one is scale. Scale means either interval or ratio. So you can see from the data that there are different restaurants which are serving different sandwiches, and there are different types of sandwiches, and the different meats are being used in order to serve those sandwiches. And the key ingredients are calories, total fat, sodium, saturated fat, trans fat, cholesterol, carbohydrate, fiber, sugar, and protein. So all these are measured in scale. These are continuous scale, and meat type, sandwich, and restaurant are measured in nominal scale. So if you see here that the first column is meat, different types of meat are being used, different types of sandwiches are here, and there are different names of these sandwiches, and the ingredients are measured, and these sandwiches are being offered by different restaurants. Here see Arby's, Burger King, then Chick-fil-A, Dairy Queen, McDonald's, so Sonic. These are the different restaurants that Wendy's. These are the different restaurants that are offering these sandwiches. So what we are going to do here, we are trying to understand that what restaurants are offering what type of sandwiches, and if we go to a particular restaurant, which restaurant we should go, which particular restaurant when we are entering, what sandwiches we should order, and how we can form groups among these sandwiches or clusters among these sandwiches in order to understand that when we give orders, what sort of sandwiches we should order. So this is the data set. So this is clear to you, the data set?
Yes, sir.
Now, first try to understand that this is the single data set. Just to give you a hands-on feel, we will be using 3 methods: hierarchical, k-means, as well as 2-step in this data set only. But generally, I have mentioned that if there are the sample sizes within 300 to 400, you should use hierarchical cluster technique. If the sample size is too large, you should go for k-means clustering technique or a 2-step clustering technique. Now here you can understand that we have 190 sample size. Our sample size is 190. This is a not so big data set. So let us start with the hierarchical clustering technique first. So I will show you that if we can split our data set on the basis of restaurants, then it will be easier to apply the hierarchical clustering technique, and it will be easier for us to interpret. If we don't split, what will happen, I will first show, then I will split the data set and show you the difference if we split and if we not split the data. So first, let us, without splitting the data set on the basis of the restaurants, let us on the whole data set, we apply the hierarchical clustering technique first. So go to analyze, go to classify. Under classify, you will find this hierarchical clustering technique. Are you with me? Can you follow me?
Yes, sir.
Yes, sir.
Yes, sir.
So just click this hierarchical clustering. You will get this dialog box. Have you got this dialog box with you?
Yes, sir.
Yes, sir.
Okay. Now, initially, let us choose that calories, total fat, and let's say sodium. These 3, we are, from our understanding, we are thinking that these 3 variables are good enough variables which will help us to form clusters. So we have chosen these 3 variables: calories, total fat, and sodium. Now we want to label cases by, we want to cluster on the basis of sandwiches offered. So I am bringing sandwich under label cases by, because the product is sandwich only. The different restaurants are offering sandwich. So label cases by is sandwich. Till now it is clear?
Yes.
sir.
Now click this statistics button. Under statistics button, you see we will be choosing the agglomeration schedule. Why? Because I have already mentioned when I was discussing the theory that in case of hierarchical clustering technique, if you want to generate agglomeration schedule, you have to have different methods. That methods may be Chebyshev or Mahalanobis or Euclidean or squared Euclidean or Manhattan distance. So we are using agglomeration schedule here. Now you may go for a single solution. Single solution may generally in social science, the clusters range from 2 to 5. If the data set is moderate enough, you will find that significant clusters will range between 2 to 5. And if there are huge data sets, then the cluster may go above 10 or 12 also. But in our social science data sets, generally the cluster size range between 2 to 5. but since we don't have any idea that what should be the exact number of clusters, let us give a range of solutions. So here we are giving, say, minimum 2, maximum 4. On the basis of trial and error method, we will understand that actually what should be the exact number of clusters. I will show you how to determine that. So initially we start with minimum 2 and maximum 4. This is clear?
Yes, sir.
So continue. Now click the plot button. Under plot button, we need to choose the dendrogram, because dendrogram is a tree graph that is very important in order to understand the exact number of clusters. So we are using dendrogram here. And otherwise all are okay. Click. So don't need this eye cycle. So I'm clicking none. We need dendrogram only. Click continue. Can you follow me? Statistics button and plots button is clear.
Yes, sir.
Sir.
Now,
Yes, sir.
yeah. Click method button. See, under method button, there is cluster method. Do you remember which method we should use among these options? I was talking about centroid and words method, and I was talking that centroid we will be using. Why? Because it is the distance between the mean of the groups. Clear? So we will be using centroid clustering technique. Have you chosen it? Please,
Yes, sir.
yeah, please unmute and talk with me. If you don't interact, I will not be able to understand whether you are following me or not. So cluster method, centroid clustering we will be using. Under interval method, I have already mentioned that we should use the squared Euclidean distance because it is the most popular. And now just try to understand that whether we need to standardize or not. What variables we have chosen: calories, total fat, and sodium. You see, calories is measured in hundreds, fat is measured in tens, sodium is measured in 1000 units. So are they in same scale?
No.
So what we need to do, we need to standardize the data set. So here, transform value standardize. You can choose Z scores or range between -2 to +1. Say, suppose you can choose any of the two. Suppose we are choosing range between -1 to +1. You may choose Z score as well, no issue. So we are standardizing the data, the variables. Then continue. Clear till now?
Yes, sir.
Under save button, you can give range of solutions that we have given 2 to 4, or you can give single solution. But since we are not sure that what should be the exact number of clusters, let us don't save the membership now. Later on we will save. First, let us run without saving the cluster membership. So here's under display statistics and plots, by default it is chosen, and we should do cluster by cases. So all these things are right. Now let us click OK. So have you got the result now?
Yes, sir.
Yes, sir.
Yes, sir.
See, so huge. See the cluster membership. It is very difficult to interpret. Just check the dendrogram now. See the dendrogram. See the dendrogram. So huge. Whether it will be possible to interpret this dendrogram?
Hmm.
It is complex. It is cumbersome. So that's why what we need to do is we need to split the data set in order to interpret it viably. Initially, what we have done, we have not splitted the data set. We have taken the data set as a whole. Now, it is very difficult for us to interpret. So what we will do now, in order to make it manageable, what we should do, we should split the data set on the basis of restaurants. How we should do that? Go to data. Under data, you will find the split file. Can you see?
Yes, sir.
Yes, sir.
So click the split file and see here, organize output by groups. If I choose organize output by groups, group based on what? Group based on restaurant. So I am putting it restaurant here. Can you follow me?
Yes, sir.
So if I group the data set on the basis of restaurants and then click OK, now see, split file separate by restaurant. So automatically they have splitted the file. Now check, when you open your data set, in the extreme right hand corner, see now it is being shown split by restaurant. Can you see?
Yes, sir.
So now we have splitted our data set on the basis of restaurants that are offering these sandwiches. Now it will be better for us to interpret when we use hierarchical clustering analysis. So we have splitted our data set now. Then we go on to analyze. Classify, hierarchical clustering technique. All these things are same. Statistics, agglomeration schedule, plots, dendrogram, method, centroid, squared Euclidean, and standardized. All things are okay now. Now click OK. Now if you click OK, see here, you will find that on the basis of restaurants, they are showing you the result. See, from the beginning, if I go from the beginning, see, restaurant RBs agglomeration schedule given, cluster membership given, and dendrogram also given, which is now much more easier to interpret because we can see it in a single picture. Clear? Now,
Yes, sir.
now let us just to give you a basic understanding, let us choose the restaurant which is the smallest one. So among the 7 restaurants, if you see, the smallest is and the simple is the Chicafila. So let us try to take this Chicafila and try to interpret that, how we interpret the dendrogram as well as the agglomeration schedule. So first you see this dendrogram of Chicafila. I am double clicking it. If you double click and click right, you can copy this. So in order to see it in a bigger volume, I'm copying it. I'm pasting it in, say our, let us paste in a separate Word file. Can you see my screen?
Yes,
sir.
sir.
So can you see this?
Yes, sir.
So you can make it big. Yeah. Now, just if you see here, initially, if you see this chicken deluxe and spicy chicken sandwich is within one group. Spicy deluxe is in another group, but they are close to each other. So they can be form one cluster. Similarly, if you see here, chicken strip, chicken sandwich, char grilled chicken club sandwich is in another group. Chicken salad sandwich is somewhat different from them, but they can be in one group. Similarly, char grilled chicken sandwich and nuggets is one group. Grilled chicken nuggets is another group. And you may see here that if I draw a diagram here, or if I draw a line here, say suppose I'm drawing a line, let us draw a line here. So if I draw a line, so suppose I'm drawing a line here. So if I draw a line here, so how many groups you may say if I draw a line here? See, we will be moving from right to left. When we are moving from right to left, you will find that more number of clusters will be generated. If I draw a line here, then how many cluster is there? 1 and 2. Now, if I again draw a line here, it will be unchanged. It will be 2 only. Again, now, suppose I am drawing a line here. If I draw a line here, how many clusters now you may say? 1, 2, 3, and 4. This is clear to you?
Yes, sir.
Yes, sir.
So
Yes, sir.
Yes, sir.
the more we move from right to left, the number of clusters will be more. Now, which is the exact number of clusters? How can we identify? Now, come here. Have you seen this agglomeration schedule of Chikafila? Have you got this?
Yes, sir.
We have used the
Yes.
Dendrograms. Now we are using the agglomeration schedule. Just double click this agglomeration schedule and just highlight these coefficients. Choose this coefficient. Just double click and choose this coefficient. If you choose this coefficient, if you click right hand side, you can create graphs. So let us create a line graph. Create graph line. See here. Can you see the line graph created?
Yes, sir.
In factor analysis, we call it as a scree plot. Here in cluster analysis, we call it as a reverse scree plot. Actually, we try to find the elbow here. Where is the elbow? So if you say, suppose I am copying it, I will paste it in Word file. It will be easier for you to comprehend them. Let me copy here. So this is clear to you now. You can see.
Yes, sir.
Yes, sir.
So here you see now. See here. This is starting from here. Here there is a bend. Here there is a bend. Here there is a bend. And after here you can see it is parallel to x-axis.
Yes.
After here it is parallel to x-axis more or less.
Yes.
So this is called the elbow, from where it is parallel to x-axis. So that is the cutoff. So here it is the cutoff. So if you see here, this is the 1 cluster. This is the 2 cluster. This is the 3 cluster. This is the 4 cluster. So ideally, you should have 3 to 4 clusters. 4 clusters should be best, not more than that. So this scree plot, the reverse scree plot or the elbow will help you to validate that what should be the exact number of clusters. So this is clear to you?
Yes, sir.
So this hierarchical clustering is okay. Generally, when you do hierarchical clustering technique, remember that if there is a huge data set, you should split the data set, you make it manageable, and then you run this hierarchical clustering technique, and you use the dendrogram and the agglomeration schedule. You try to create the scree plot, the reverse scree plot on the basis of this coefficients of the agglomeration schedule, and the line graph or the scree plot will help you to validate that what should be the exact number of clusters. This is clear, I think, now.
Yes, sir.
So if you have any doubt regarding the validation, you may ask me. I think I have gone slowly. So you have done along with me. Just I have shared with you the data set. In your convenient time, you just practice, and then you will be able to grasp it in a much stronger fashion. So now let us go to the k-means clustering technique now. I will tell you that in case of hierarchical clustering technique, we need to split the data set. But in case of k-means or two-step cluster analysis, they can handle the huge data set. So there is no need to split the data then. So let us again go to data, split file, and we just now don't want to create this. We choose it. We analyze all cases, do not create groups. We choose this one and we click OK. So split file is off now. So now you see in the data set, split by restaurant gone. Can you see extreme right hand side? Split by restaurant gone. It is off now. Have you done this?
So
So it's on.
So it should be off. When doing hierarchical clustering, it should be on. When doing k-means or two-step, we should de-choose the split file, or we should deactivate the split file. Okay. I think you can follow me. I will proceed with the two k-means now.
yes, sir.
Okay. So when we have desplitted the file now, so as a overall, we will analyze. Now again, go to analyze, go to classify. Now click this k-means clustering technique. Analyze, classify, k-means clustering technique. You will be having this dialog box.
Yes, sir.
Now, let me tell you that when you are doing a hierarchical clustering technique, in the dialog box itself, there is scope that you may standardize your data by choosing z-score or -1 to +1. There is scope of standardizing the data. But in case of k-means clustering analysis, there is no scope of standardizing the data within the dialog box. So before running the k-means clustering technique, you have to first standardize the data, then go on to run the k-means. This is very important because you know that when you are choosing calories or total fat or sodium, all are in different scales, different units. So we need to standardize it. In our theoretical concepts, I have mentioned that when you are doing a cluster analysis, you have to standardize the data set first before doing cluster analysis. Otherwise, the results will be bad or insignificant. Clear? Till now it is clear to you?
Yes, sir.
So what we should do first, we should standardize. So go to analyze, go to descriptive statistics. Under analyze, under descriptive statistics, see here you have descriptives. Can you see?
Yes, sir.
So click these descriptives. You will have this dialog box. What are the variables we need to standardize? We have started with calories, total fat, and sodium. Calories, total fat, and sodium. And just see here in the left hand corner below, save standardized values as variables. Can you see?
Hmm.
Just click this. Just click this. Save standardized values as variables. Have you clicked it?
Yes.
Now click OK. If you click OK, here you will see the minimum, maximum value, standard deviation all given. No need to check this. Just go to the data set now. See here. Standardize Z calories, Z total fat, Z sodium, means all the three variables are standardized now. Have you got it? So we should run k-means cluster analysis on standardized value, not on original value. Clear? If the values are different, if the measurements are different. So now go to analyze, go to classify, go to k-means cluster analysis. I think you are able to follow me.
Yes, sir.
So now, yes, pardon. So what we should do now? We have to bring this Z score values, calories, total fat, and sodium. Clear?
Yes.
Now,
Yes, sir.
if you click iterate column, see maximum iterations by default is 10. It means that within 10 iterations, it will give you results. SPSS will give you the clustering result. So no need to change anything. Just click continue. Now click save. If you want to have cluster membership, you may click it, but we are not sure whether 3 or 4 is best. So I will initially do a trial and error method, and then I will save this cluster membership. So now I am not doing. Options, initial cluster centers, and ANOVA table you should select, because ANOVA table will help us to understand that what should be the exact number of clusters and how far the variables are helping us to create clusters. So we choose this ANOVA table here. Okay. Click continue. Now here number of clusters. Here 2 is given. Let us start with 3. Then we go on to 4 and 5, and we will check that which is the exact number of clusters. So let us start with 3. Now click OK. Have you got the result like me?
Yes, sir.
See here.
Yes, sir.
If you see the iteration history, you see that in 6 iterations, it has converged to 0. So if when it converts to 0, it means that our cluster is stable. It is good. It should converge to 0. That is one validation technique. So here we can see that in 6 iterations, it has converged to 0. Good. Now come to the ANOVA table here. If you see the ANOVA table, you will find the F values are larger and all are significant. Means the calorie, the total fat, and the sodium have actually, they are significant variable in generating cluster membership, and the clusters have converged to 0 in 6 iterations, means that our cluster is stable. This 3 cluster is good cluster, and the variables that we have chosen are all significant variables in order to form this cluster membership. This is clear?
Yes.
If it would have been greater than 0.05, if the significance value or the p value would have been greater than 0.05, then we would have dropped that variable. But since this is significant, we will take all these 3 variables. Only if it is greater than 0.05, we will drop that variable. Means that variable is not significant in generating cluster membership. This is clear to you?
Yes.
Now you see the number of cases in each cluster. See, in cluster 1, there are 14 sandwiches. In cluster 2, there are 107 sandwiches. In cluster 3, there are 69 sandwiches. So cluster 1 is means underrepresented, but still we can choose these 3 clusters. Why? Because all the variables are significant, as well as it has reached 0, converged to 0 in 6th iteration. Clear?
Yes.
Now, another very beautiful validation technique I was talking about, that you have to validate that. The more you validate that your cluster is good, the better will be your study or research output. So what we can do, you just double click this final cluster centers. When you double click this final cluster centers, and if you choose these values, you highlight these values and you create, right click, you create graph, create a bar graph. See here. Graph is much more easily interpretable than numbers. So if you see the graph here, have you generated this graph?
So once again, I repeat.
Yes, sir.
Just double click these final cluster centers and you choose these values. You highlight these values and you create, right click, create graph, bar graph. You will get this diagram.
Okay, sir.
Now you see that how many cluster is here? Cluster 1, cluster 2, and cluster 3. And you see blue is calories, green is fat, and tan is sodium. So you see that there are differences in 3 clusters. Why? Because both calorie, total fat, and sodium is higher in cluster 1, is much lower in cluster 2, in cluster 3, and it is in negative in cluster 2. So suppose you are a customer and you have visited a restaurant and you are a health conscious customer. So which cluster of sandwiches you should choose? From which cluster of sandwiches you should choose?
So 2 or 3.
Yeah, 2 or 3. So this is clear. I think you have got the spirit of the graph.
Sir, it's much clearer with the graph because you can see the.
Of course, but these validation techniques you should know. Okay.
Yeah.
So I think it is interesting now. You can interpret this. So I will move forward.
Okay, sir.
So now it is clear to us that this 3 is good. 3 are. Now what we can do is we can go to our original data set. We have not saved the cluster membership, that which sandwich will fall in which cluster, that we have not done. Now since it is validated that these 3 cluster are good enough, now we can go to analyze, we can go to classify, we can go to k-means, and just we can click this save button and click this cluster membership. Just do this one. Just click the save button and click the save cluster membership. Just click continue, and if you click OK, now you see the data set here. Automatically see here the cluster membership is generated. So first sandwich will fall in cluster 2, second will fall in cluster 2, third will fall in cluster 2, fourth will fall in cluster 3. Likewise, it is being generated. Clear? Now what we can do is, again we can validate this with the help of another technique. That is, if you go to analyze, if you go to compare means, if you click one way ANOVA, and what are the three variables we have chosen? Calories,
Yes.
fat,
Fat,
and sodium,
sodium,
and the factor will be the cluster number that we have generated, 3 cluster number. So we are choosing cluster number under factor, and under post hoc button, just click this Bonferroni or Taki. You may choose any of the two will do. This is a post hoc test. I will tell you the result, the interpretation. Just we are choosing Bonferroni here. Click continue. If you click OK, see here. If you see the multiple comparison table here, you see this is a comparison between cluster 1 and cluster 2, cluster 1 and cluster 3 for calories, similarly for total fat and for sodium. And if you see the significance value, all are less than 0.05 and less than 0.01, means all are significant. Means that the 3 clusters are significantly different from each other. And all these 3 variables are also very significant enough in order to generate this cluster membership. So if you generate this table and if you interpret this post hoc test and if you prove that all are significant, then it is validated. Your result is validated that the variables that you have chosen and the cluster membership you have generated are all good and best. Clear?
Yes, sir.
So any doubt till now you may ask me, or otherwise we will proceed towards the 2-step cluster analysis. If you want to repeat anything, I can repeat. If you have not followed anything or if you have any doubt.
So the last step, one way ANOVA just mean step by step, go forward step.
Just go to the data set. When you have created the cluster membership, after you have created this cluster membership that you can see here, we have created the cluster membership, we have saved it. Now what you need to do is, you go to analyze, go to compare means. Under compare means you have one way ANOVA. You click this one way ANOVA, and what you do is, again I am showing you. What you will do, you will bring all the 3 variables, the standardized value of the 3 variables, that is calories, fat and sodium, under dependent list. And then you bring this one. This is the cluster membership under factor. And you click this post hoc button. Under post hoc, you choose either Bonferroni or Taki, will be giving same result. Click continue. And then if you click OK, you will get this multiple comparison table. And if you see the significance value, here 3 clusters are generated, 1, 2, and 3. And all the 3 variables are being compared with one another in terms of cluster. So cluster 1 compared to cluster 2, cluster 1 compared to cluster 3, similarly cluster 2 compared to cluster 3, cluster 2 compared to cluster 1. Likewise, multiple comparisons are there on the basis of the 3 variables among the clusters, and if you see the significant value, all are significant. It means that our 3 clusters are best clusters, and the variables that we have chosen to generate the cluster membership are also significant.
Okay.
So this is how we check that whether our variables are important or not in order to generate cluster membership. In the theory part, I was telling that you have to discard the trivial variables or the unimportant variables, and you have to keep the important variables. This is how we keep the important variables. If the variables are not significant, we will drop that variable. I think it is clear now to you.
Yes, sir.
So I think hierarchical and non-hierarchical or k-means is clear to you now.
Yes, sir.
Yes, sir.
Yes,
So
sir.
let us finish today with the third method, that is the hybrid one, that is called the two-step cluster analysis. So just remember that if you have a large data set, in order to run hierarchical cluster technique, you need to split the data set. But in case of k-means or two-step cluster analysis, you don't need to split the file. So we are running without splitting the file, the two-step cluster analysis. So go to analyze, go to classify, here see step cluster. Can you see?
Yes.
So click this two-step. You will get this dialog box here. So what we will be, categorical variables are ordinal or nominal variables, and continuous variables are scale variables. So we have chosen calories, total fat, and sodium. All are continuous variables. So we have chosen, we have brought this under continuous variables. And under option button, no need to choose anything, just click continue. Under output, what we need to do is, we need to click this pivot tables and we need to evaluate our result on the basis of other variables which we have not chosen to generate cluster membership. So we have chosen three variables: calorie, fat, and sodium to generate cluster membership. So we can choose other than those three variables to evaluate. So let us say we are taking, say, suppose protein for evaluation. We can take restaurant also for evaluation. Suppose we are taking protein and restaurant here, which we have not taken to generate cluster membership. So we have taken calorie, sodium, and fat, total fat. That's why we are taking other than those for evaluating. So let us say we are taking two, protein and restaurant, and we are create cluster membership variable. So we need to create this cluster membership. Click continue. And now here, just try to understand that from our understanding of the data set, we can see that 3 and 4 are the good cluster numbers. So if you specify the cluster number, suppose I am specifying the number of clusters because I know already. So if I am specifying, say, 4 or say 4. So when you are specifying the cluster membership on the basis of your prior knowledge, you have to choose Euclidean distance. Just try to understand this. When you are specifying the number of clusters on your own, on the basis of your previous knowledge, the distance measured should be Euclidean. But suppose you don't have any understanding that what should be the exact number of clusters, you are actually letting the software to do. So you are choosing determine automatically. Determine automatically means SPSS will generate the cluster membership on your behalf. So when you are choosing this, you have to use log likelihood. So when you are letting the software to choose the number of clusters, you have to use log likelihood distance measure. And when you are using your own previous knowledge and you are specifying the number of clusters, you have to use Euclidean distance measure. Not only that, suppose you are using the softwares to generate the membership, you are using log likelihood distance. Here also you should choose AIC, Archaics Information Criteria. Why? Because under clustering criteria, the theory tells us that AIC is better than BIC, the Schwartz Bayesian criteria. So AIC is better than BIC, the theory tells us. And the objective of any cluster analysis is to reduce the AIC as much as possible. So minimization of AIC is one of the most important objective of doing cluster analysis. So here we will be choosing AIC in order to reduce it or minimize it as far as possible. So let us choose this AIC here, log likelihood, and let us software determine this number of clusters. This is clear?
Clear, sir.
Yes, sir.
So click OK. Now see, if you see here, the model summary, if you double click, you will get many things. Check here. If you see here, inputs is 3. Input means 3 variables we have chosen. The software have generated 3 clusters. And if you check here, these blue bar should be in good or at least fair in order to generate a good cluster quality. See here, it is written cluster quality. Cluster quality on the basis of silhouette measure of cohesion and separation. Cohesion means homogeneous within groups and separation means heterogeneous across groups that I was talking. So silhouette measure actually helps you to generate clusters or groups which are homogeneous within each other and heterogeneous across each other. And if you see here the result, it is touching good. So 3 cluster membership is good enough. And here also, if you see the cluster size, so third cluster have 16.8% of cases, second cluster has 37.4% of cases, and first cluster has 45.8% of the cases. And here also you should try to understand the validation is the ratio of largest to smallest cluster should be less than 3. If it is less than 2, it is much better. Means it is best result if it is less than 2, but it is acceptable if it is less than 3. Clear?
Clear, sir.
Now if you click here under view, if you click clusters, see here, you will 3 variables, calories, total fat, and sodium is being generated. And you can see here that in cluster 1, 45.8% of the cases are in cluster 1. Here, the most important variable is calories. Why? Because calorie is 543.79. Here, if you see in the second cluster, the calorie is 346.76. In third cluster, you see the calories is 871.25. So in terms of calories, third cluster is highest, second cluster is in the middle, and first cluster is in the middle, and second cluster is in the third. So maximum calorie is being shared in cluster 3. Similarly, if you check the fat, you will find maximum fat is in cluster 3. If you check the sodium, maximum sodium is in cluster 3. So as a health conscious customer, we should avoid cluster 3 while choosing sandwiches. Clear? Not only that, if you click display here, what are the variables we have chosen for evaluation? Protein and restaurant. See here, evaluation fields, protein and restaurant automatically come. If I click OK, see here. In the evaluation fields also, protein and restaurant is showing here. So if you see here, which restaurant is offering huge calorie, fat and sodium? Restaurant Sonic. So we should avoid restaurant Sonic. Whereas we should accept McDonald's when we are purchasing low calorie, low fat, low sodium sandwiches. This is clear to you? From the result, you can interpret that which restaurant is better for choosing health conscious sandwiches. This interpretation is okay. Can you understand this?
Yes, sir.
Now, if we choose this one, see here, cluster comparison is being given. So how many restaurants were offering sandwiches? Arby's, Burger King, Chick-fil-A, Dairy Queen, McDonald's, Sonic and Wendy's. And if you see this box plot here, the middle line is the median value. Middle line is the median value. And if you see the calories, it is a little higher. Total fat is also higher than the median. Sodium is also higher than medium. Protein is also higher than medium. The restaurant which is serving is McDonald's. Now, if we compare all the three, we have to choose three at a time, simultaneously. If we choose three simultaneously, cluster comparison is being given. So if you now compare, this blue is Sonic. So Sonic is actually offering sandwiches which are higher in terms of calorie, total fat, sodium and protein if you compare with McDonald's. McDonald's is offering both low calorie, low fat as well as medium sized calorie fat products. So you can choose on the basis of your appetite. If you are a super health conscious customer, you will choose the red color sandwiches or the cluster. Which cluster you should choose? Can you tell me? The second cluster, cluster 2. Cluster 2 is red. So cluster 2 has the lowest sodium, protein, total fat and calories offered by McDonald's. Clear?
Yes, sir.
Now, these things you can use in your output as well. In your study, you can copy this in your these things and you can paste it in your Word file and you can interpret. How we can copy this? Just go to edit. Under edit, see here, copy main view means this you can copy. Copy auxiliary view means this. So suppose I am copying this one, cluster comparison. So I am clicking copy auxiliary view. When I have copied auxiliary view, just go to the Word file. See here, it has come. So you can make it big, you can make it small according to your analysis, according to the size of the paper or how much size you want to make, and you can interpret below the table. Clear? So I have tried to demonstrate to you all the three methods which are used in cluster analysis. In a short span of time, I have tried to do the best possible for me